Good morning, everyone. We are live at the National Tropical Weather Conference on South Padre Island, where today is the day that the seasonal forecast is announced here at the National Tropical Weather Conference. Dr. Phil Klotzbach from Colorado State University, Colorado State, the pioneer in hurricane forecasting, and today is the day they announce what they expect to happen during this hurricane season. So in just a moment, we'll take a peek inside the door. You'll hear Dr. Phil give maybe 5 minutes. He'll give the forecast, and then he'll spend the next hour talking about why he's forecasting that. So it's going to be a fascinating day. We are again at the National Tropical Weather Conference on South Padre Island, Hilton Garden Inn. Let's take a peek inside the door now, where Bill Reed is on the podium, and he's ready to introduce our speakers. This is Bill Reed.
Because without him, we can't have a conference. So, Rob?
Thank you very much, Bill, and good morning, everyone. I want to welcome all of our conference attendees for attending this year. So for those of you that are returning, welcome back. For those of you that it's your first time here, I hope you enjoy the conference. This is really feels like a family affair, and that's really thanks to our host, Alex Garcia, and many of his family members work behind the scenes, as well as Tim Smith, our co-host. Let's give them a round of applause. So USA, as most of you know, but maybe not everybody, is a property and casualty insurance company and a large financial services provider that's headquartered in San Antonio, Texas. We were founded by 25 Army officers in 1922, and I like to tell people that we're a startup company, just a 95-year-old startup company with over 12 million members today. We're one of the largest property casualty insurers in the country, focusing on serving military members and their families. One of the things that's very important to us, and the reason that we're proud to be the title sponsor, is preparedness during hurricane season. Both preparing the home, preparing an evacuation plan and a communications plan, know where your zone is, get out of harm's way, and also prepare yourself financially. Understanding what your insurance coverage is ahead of time, making sure that you have proper limits, that you have windstorm coverage, and also understand the importance of flood coverage, as we've seen through events like Harvey and elsewhere. So we're very proud to be the title sponsor for the second year here at the National Tropical Weather Conference. It is my pleasure to introduce our speaker this morning, Dr. Phil Klotzbach of Colorado State University. Phil is a research scientist in the Department of Atmospheric Science at Colorado State University. He was a co-author on the Atlantic Basin Hurricane Forecast with Dr. William Gray. Dr. Klotzbach developed the 2-week forecast currently being issued during the peak months of the hurricane season between August and October. He also developed the Landfall Hurricane Probability webpage in partnership with the Geographics Laboratory at Bridgewater State College. The webpage provides hurricane landfall probabilities for the entire United States coastline from Brownsville, Texas to Eastport, Maine, as well as the Caribbean. And I know that we're very eager to await Phil's seasonal outlook for 2018 hurricane season. We know 2017 was quite active, so be very interested to see if we're going to have another active season in 2018. Please join me in welcoming Phil Klotzbach.
All right, well, good morning, everyone. Thanks all of you for turning out after a fun night last night on South Padre. And thanks to Alex and Tim for having me back. This is my fifth straight National Tropical Weather Conference. Unfortunately, I was not here for the first one. I was actually working in Australia, so I had to pass that one up. But ever since, always here in South Padre. And yeah, we're going to talk about the seasonal outlook for 2018 and a variety of other factors as well. I figure we'll start with the numbers for 2018, then I'll cover a few other topics, and then we'll go back and go into a lot of more detail on what we're expecting for 2018. So this is the seasonal forecast that we just put out a couple of minutes ago. Hopefully, if TweetDeck worked, everything should be out on Twitter and posted live on our website. We shall see. We're forecasting a slightly above normal season, a total of 14 storms, 7 hurricanes, and 3 major category 3 to 5 hurricanes. Accumulated cyclone energy of 130. For comparison's sake, last year was, I believe, 226. May go up or down slightly with the reanalysis of all the storms at the end of the year. But we're forecasting a slightly above average season because at this point, we don't see the potential development. We don't think that a significant El Nino is going to develop this year. One of our primary reasons, the Atlantic right now is a little warm in the western Atlantic, a little cold in the eastern Atlantic. It's kind of marginal. Some of the models are indicating a decent amount of anomalous warming. So we'll talk a lot more about 2018 and what we're expecting in the next, in about 20, 30 minutes or so. But I wanted to cover a few other topics before we get there. So if everyone has the numbers for 2018, we'll move on, and we're going to start with an introduction, basically discussing how we do seasonal hurricane prediction. Unlike what some of our critics might say, we're not throwing darts at a board. We do use a statistical model which does show historical skill. This is our 35th year of doing seasonal hurricane forecasts, and the fact that people are still paying attention to them indicates that there is a little bit of a method to our madness. And obviously, I'll talk a lot more about Dr. Gray, and I'll be mentioning some anecdotes about Dr. Gray throughout the talk, because he obviously was the guy who started this whole business. We'll talk about tropical cyclones and climate change. Obviously, this is an area that basically gets talked about anytime you have a pretty nasty hurricane season. So we'll talk a little bit about basically why or how we think tropical cyclones and climate change interact. We'll talk about what happened last year, how we were the seasonal forecasts. Obviously, we've already heard a lot about what happened last year. Briefly recap a few of what I think are the most notable factors. Then we'll spend a lot of time talking about 2018, what we're thinking we're going to see for 2018. Then I'll highlight a couple of new products that I've been working on over the last couple of years that I think you guys might find of interest. But whenever you're doing a seasonal hurricane forecast for hurricanes, you certainly would be remiss if you didn't acknowledge Dr. Gray. Dr. Bill Gray was a giant in the field of hurricanes. Not only did he develop the seasonal hurricane forecast, by the time he had done that, he had already been studying hurricanes for about 30 years. So he had already made fundamental contributions to things like tropical cyclone genesis, intensity change, tropical cyclone structure, and just tropical convection, so basically cloudiness. He'd done a lot of fundamental research even before doing the seasonal hurricane forecast. And if you're interested, we just published a paper a couple months ago in BAMS on Dr. Gray's research legacy. It's myself and several of Dr. Gray's other PhD students. And he really did. He just had a lot of really impressive contributions. It's a very long paper just because there was so much stuff that the guy did. And besides being a really good scientist, he was my mentor, my PhD supervisor, a really good friend, and honestly, in a lot of ways, it felt like he was a lot more like, in a lot of ways, I felt like he was my grandfather. And early on, when people first saw me going with him, they used to say, "Oh, Dr. Gray, did you bring your grandson along?" So we used to joke about that too. But Dr. Gray was very, very passionate about hurricanes, and he wanted the hurricane research to continue. He told me when he died, he told me right before he died, I want 50 more years of seasonal forecasts out of you. So I said, I can't guarantee you 50 because I don't really want to be working when I'm 87. But we'll try to continue these forecasts. And I have a new co-author, Michael Bell, who started working with me last year on the seasonal forecast. He and I went to grad school around the same time. He joined the CSU faculty a couple of years ago. And it was actually neat because about 2 weeks before Dr. Gray died, Michael had accepted an offer to join the faculty at CSU. And Dr. Gray was very, very excited that we had another hurricane scientist coming to CSU. And Michael's helping to carry the torch at CSU, and hopefully will continue to be a leader in our department for hurricane research, because we always say we study hurricanes in Colorado State because a storm surge can't get you at 5,000 feet. So unlike my meteorological namesake, Punxsutawney Phil, we do have there is a bit of a method to our madness when it comes to the seasonal hurricane prediction. We're not waking up like these dudes and seeing if we can see our shadow. What we do is we use historical weather data and historical weather information to develop our seasonal forecasts. So while we would agree with the great philosopher Yogi Berra that it certainly is tough to make predictions, especially about the future, as I'm sure all of you in meteorology would agree, forecasting the weather and forecasting climate is really, really hard. And unlike when you're forecasting the weather, if you have a bad forecast, people might give you some grief for it, but there's always tomorrow's weather. Whereas when you do a seasonal forecast and it doesn't go well, you get to hear about it for an entire year. You don't have that quick turnaround time. So we really do try to do, obviously, the best that we can. And we do find, like Yogi Berra also said, that you can see a lot by looking. Basically, by going back into the past, we can find clues and precursor signals that tend to tell us whether the seasons are going to be active or inactive. So prior to when Dr. Gray started these forecasts in 1984, we had really no way to know whether the season was going to be above or below normal. And so Dr. Gray noted in some early research, he said, okay, he knew which years were El Nino years, and he also knew which years were active Atlantic hurricane seasons. And he said, when we have El Nino, we don't tend to get active hurricane seasons. And so it was a matter of trying to figure out physically why would something going on with ocean temperatures in the tropical Pacific impact hurricanes in the Atlantic. And so what we have is we have a really good extensive database going back quite far of the number of hurricanes. The hurricane database goes back to 1851. Obviously, as you go back in time, there's issues with observations, but we have probably 50, 60 years of good hurricane data. And we have good data now of water temperatures, pressures, winds on grids going back all the way to 1950, even earlier for some of these data sets. And so one thing that Dr. Gray used to tell me was back when he started doing the seasonal forecast, you had to basically call up people and get them to send you station data and get individual buoys. He's like, you guys have it easy. Now all you can do is just go to your computer and generate these figures. So I think it was certainly a testament to his creativity, though, because he kind of had to know what he was looking for. It's a lot easier now because we have so much more data and obviously a lot more computational resources to find predictors for the Atlantic hurricane season. So there is there are some kind of precursor signals, and there are some signals that tend to dominate in active versus inactive seasons. And this kind of shows you what we're looking at. This is August through October, so the peak months of the season. The 10 most active hurricane seasons, difference from the 10 least active seasons. And yellows mean warmer and active seasons, blues mean colder and active seasons. So if you look at the Atlantic, you see, hey, there's warm water in the North Atlantic as well as in the tropical Atlantic. Oh yeah, this spotlight is awesome. So you can see warm in the northern Atlantic, warm in the tropical Atlantic. And again, you would expect warm tropical Atlantic means more fuel for developing hurricanes. But also, it's not just the warm waters themselves. When you have warm waters, it tends to alter you get lower pressures, you get weaker low-level winds, you tend to have less vertical wind shear, more mid-level moisture. Just all these conditions tend to go together to generate more hurricane activity. Likewise, if you look at the tropical Pacific, you get this big cold blob, which is La Nina, basically, a La Nina signal. La Nina is basically the opposite of El Nino. And when you have a La Nina, basically what happens is it tends to alter upper-level winds in such that they're weaker out of the west. So in the Atlantic, if you consider the winds in the vertical, at low levels you have your trade winds, the winds that blew the explorers over to the New World. These winds blow out of the east. And at upper levels, the winds blow out of the west. So in the vertical, you have a shear that is typically there in the Atlantic. And the shear in the Atlantic is somewhat marginal, which is why we see such massive year-to-year variability in the Atlantic. We've had years like 2013 where we had 2 hurricanes all year. They lasted like 3 total days. If you took a vacation for one weekend, you could have missed them both. Whereas you can obviously have a year like last year with 10 hurricanes, and even 2005 that had 15 hurricanes. It's a very marginal basin. So if you get significant reductions in shear like we get in La Nina, or you get significant increases in shear like we get in El Nino, you can get really big differences in the number of hurricanes that form. And that's one of the reasons why Dr. Gray started doing these seasonal forecasts for the Atlantic, is because you have such marked year-to-year variability that there's a lot of potential predictability given these very strong climate signals. So typically in the Atlantic, El Nino is our friend because it increases upper-level westerly winds, which increases the shear. Too much shear basically tilts the hurricane circulation. You don't get the pressure fall that you need to accelerate the winds that cause the really strong tropical cyclones. It's not to say you can't get nasty storms in El Nino seasons, but the odds go down. And again, when you're doing these seasonal forecasts, you're obviously looking at long-term odds and kind of long-term how these physical features relate. So now I want to go on and talk a little bit about tropical cyclones and climate change. Obviously, this comes to the general public's attention. Anytime you have a natural disaster, people always say, okay, was this caused by climate change? And obviously, that's a really, really hard question to say, you can't answer that question yes or no. It's always, well, climate change may have impacted it, X percentage amount. And so what we actually did is we had actually written a paper on kind of what is driving the observed increases in damage. When we wrote this paper, there we go. We wrote this paper and actually submitted it 2 weeks before Hurricane Harvey. So we had to do some significant edits when we got the reviews back from the paper after the hurricane season. But obviously the general public looks and says, okay, the storms are causing more damage, and that's what gets the public's attention. And so the question is, what is driving these increases in damage? And Louis Cellini talked a lot about some of this stuff as well. So if you're interested, this is a paper that's in press for the Bulletin of the American Meteorological Society. If you go to their website, it is online, freely available if you're interested in kind of some of the demographic analysis that we did in this paper. But obviously you can see the damage levels are way up. And so the question is, what's causing these increases in damage? And there's obviously a lot of factors involved. But obviously one of the big factors is we've had really pronounced demographic changes in the United States since 1900. It's a little different here than it was in 1900. So if you're looking... I'm trying. I can keep talking. I can just, All right, so anyway, what we did is we did a lot of demographic analysis. So one of the things, obviously, is the population of the United States is obviously increasing. And so this figure shows the population of the United States by region. And obviously, since we're focusing on hurricanes, we're not going to look at the Midwest. We're going to focus on the Atlantic and along the Gulf Coast. And so this is analysis since 1940. You can see the Atlantic coast population has gone up from about 50 to 100 million. The Gulf Coast from about 15 to 60 million. So we've increased the population of states along the coastline by about 150 million. So there's a lot more people basically in the lane that hurricanes travel than there were, say, back in the 1940s. And there, Dr. Gray used to always emphasize that, in about the late 1960s and early 1970s, it's when air conditioning came in and became affordable. So places that otherwise were really, really, really uncomfortable in the summer wasn't so bad when she had air conditioning. So we had large growth in population. And also, especially for Florida, we went from 1965 with Hurricane Betsy to 1992 with Hurricane Andrew, where basically, except for a little part of the Florida Panhandle with Eloise, they hadn't experienced any significant hurricanes during a time when there was very large population growth. And again, unless you were in southern Dade County, like John talked about yesterday, most of Florida was not impacted by a major hurricane when Andrew came ashore. It was just that southern part of Dade County where the winds were incredibly strong. So you had a large growth in population, and obviously when you have more people, that's increased potential for damageability. And you also have more stuff, which again is a good thing. We have more than our parents and our grandparents did. Back in the 30s and 40s, you were lucky if you had one car, and now people have 2 and 3 cars. We have obviously all the electronic gadgets and gizmos. Even if you look at just the square footage of the average single-family home, it's gone up from roughly 1,600-ish square feet in the mid-70s to over 2,600 square feet in the recent years. And one of the things we always emphasize, one of the things too is, especially in coastal communities, these growths may even be somewhat larger if you just were to look at coastal counties, because a lot of these counties used to have, kind of your oceanfront cottages, and now they've been knocked over and replaced with very large houses. So there's a lot more stuff in harm's way as well. So on that cheery note, what we then try to do is say, okay, let's take historical hurricanes and see how much damage would they do if they were to make landfall today with today's values of population and wealth along the coastline. And so if you normalize the time series, you can see, for example, 2017, a big spike. This is continental U.S., so this does not include Hurricane Maria. But for continental U.S., 2017, a big spike with Irma and Harvey. You can obviously see Katrina, Rita, Wilma in 2005, and the spike with 2004 with all the Charlie, Francis, Ivan, and Jean. Hurricane Andrew, you can go back and see little blips with Hugo, and you go back, there were a whole pile of storms in the 40s and 50s. You can go back to early in the 20th century. We had the 1900 Galveston hurricane, which was likely the deadliest hurricane for the continental U.S. 8,000 to 10,000 people died. But then there's this really, really large spike in 1926, which was actually talked about somewhat yesterday, which was the Great Miami Hurricane of 1926, which was a large in size Category 4 hurricane, went right into downtown Miami. And that was, say, 3 days out. It was very similar to the forecast track that Irma was potentially going to take, say, 3-4 days prior to when it actually made landfall. And we use a simple normalization technique, but if you look at the data from the risk catastrophe models, you get similar numbers. Estimated to do over $200 billion in economic damage if this storm were to make landfall today. A large in size Category 4 hurricane into downtown Miami, so you'd have all the surge and winds in downtown Miami. Coming from the east, the north side would be the stronger winds in the Iowa. You get surge and wind into Fort Lauderdale, up into West Palm Beach. And obviously in 1926, like 8 people lived in Miami. So while it was devastating for that part of Florida, there wasn't nearly obviously the population. You have basically looks like one hotel on Miami Beach. Obviously now we have a whole lot more stuff on Miami Beach than we did 90 years ago. And so this is a $200+ billion disaster. And again, this is nothing to say with climate change. This is just what's happened in the past. And Dr. Gray was always very passionate about that. He always said, we need to look and we need to know what we've seen in the past, let alone what's going to happen in the future. We know this storm did occur. And it's the second most damaging natural disaster that's occurred, say, since 1900. The most damaging one being the 1906 California earthquake, which I think they estimated somewhere around $300 to $400 billion if that were to reoccur. And if you look at the trend in landfalling hurricanes, the trend actually until last year was actually significantly downward. But last year, the trend is slightly down, but it's not significant anymore. And we started this analysis in 1878 because the U.S. Signal Service Corps was tasked by the government that said, you guys need to do a better job of keeping track of all these hurricanes. And so the trend in landfalling hurricanes is basically not significant. So there's no significant trend in the number of hurricanes, which if you're not seeing a trend in damage, would kind of make sense. There's no trend in the number of landfalling hurricanes. And obviously, you want to look at major I guess I got rid of the major hurricanes. But if you look at the major hurricane plot, similarly, no trend in the number of landfalling major hurricanes. But obviously, this is a very small subset. When we're looking at climate change, you need to move and look beyond just what's going on, making landfall, because that's obviously a very small subset of the overall number of hurricanes. So if you look at the overall number of hurricanes in the Atlantic, the number is up. And this would be a significant increasing trend since the late 19th century. But obviously, we observe hurricanes a little bit better now than we did in the late 19th century. We didn't have satellites prior to the mid-60s. We weren't flying planes in the storms prior to the mid-40s. And even in the late 40s and 50s, aircraft reconnaissance there was some, but there wasn't a ton. There wasn't the constant recon that we have now, and we know that there's storms out there. So what a couple of NOAA scientists tried to do was say, okay, we know where the ships were, because basically prior to satellite, the only way we knew that storms were out there was either aircraft prior to the mid-40s, or else either it hit land or ships encountered them. And ships tend to be somewhat risk-averse. They don't like to go and sail right through nasty hurricanes. So what they try to do is say, let's take the observed ship traffic that we know is there, because we have all sorts of ship logs going back to the early 1800s, and say, how many storms do we think we may have missed? That we just missed, just given the observational network that we had. And when you do that, this increasing trend looks very, very similar to the overall trend in hurricanes. Basically, or landfalling hurricanes, rather. Basically, an insignificant downward trend. So no significant trend in the number of hurricanes going back to the late 19th century. And so when you look at climate change, a lot of the argument is that the strongest storms are going to get stronger. We may actually see fewer overall hurricanes, but the strongest storms may get a little stronger. And so what I did in this next figure is just look at the strongest of the strong hurricanes, and basically looked at the strongest hurricane that formed each year. How strong did it get? So with Irma, it maxed out at 155 knots. In the weather business, we still like our knot. We like to use our knots. And if you go back to 1950 and you look at that quantity, there is a slight increasing trend. You could argue there could be potentially some observational issues there, but there is a slight increasing trend, which would potentially be in line with what some of these climate models are showing. But there's also a lot of year-to-year variability, so this trend is not, again, significant. And that's because you have a lot of year-to-year variability driven by things like El Nino. You had a year like 2013 where your strongest hurricane was a Cat 1. And then obviously you have a year like 2017 where you have a whole pile of storms, including several Cat 5s. So anyway, you have to deal with these kinds of issues when you're looking at these long-term trends. And I think that's the challenge, is that people always want to say, are hurricanes getting worse? And I think the challenge is that it's a tough question to answer if you're saying, are the strongest winds getting stronger? And that's because there's a lot of this year-to-year variability. And if you go outside the Atlantic, you just have satellite data. When you only have 30, 35 years of reasonably good data, it's hard to make really confident assertions in the observational data. I think some of the modeling studies and some of this type of indicates that, yes, probably the strongest storms are maybe getting a little bit stronger. But there's a lot of other things that we need to be concerned ourselves with. I think we know sea levels are going up. So even if the hurricanes don't change at all, sea level rise is going to cause increased inundation. The important point with sea level rise is that it's not going up the same everywhere. So some areas sea level's going down slightly. Other places it's really going up in a hurry. You have land subsidence we need to worry about as well. There is a lot of question about rainfall. In general, a warmer atmosphere is going to generally, for the same storm, would produce more rain. There's a lot of questions with Hurricane Harvey, how much rain was potentially CO2 driven. I've seen several papers anywhere between like 5% and 30 to 40%. That high number seems kind of excessive, but 10% more rainfall could certainly exacerbate issues. And I think also in terms of land use changes, that can cause significant issues too. If you build in an area that formerly was a drainage, say like a bayou, that can obviously, what was a permeable surface is now impermeable. You get a lot more runoff. Can cause all sorts of problems there. But I mainly stick to the physical science when it looks at the tropical cyclone intensity. And so that's basically the best thing I can say at this point is we don't see any particularly significant trends in the winds associated with the hurricanes. But there's a lot of still uncertainty in that. But the best climate models are basically saying probably slightly stronger, maybe a few fewer hurricanes, but there's still there's a really large error bars on these quantities, and that's because a lot of these climate models don't do even a great job producing tropical cyclones. So there is still a lot of uncertainty in that particular question, but we definitely see increased damage with increased buildup along the coastline. And obviously the hope is that by building smarter, improving building codes, things like that, we can hopefully not have that large damage trend continue to go up like it's been going up since 1900. And then obviously 2017 is one of the reasons why obviously I had that last section. If it wasn't for 2017, I probably wouldn't have talked about tropical cyclones and climate change today. It was a very active season. Obviously, we've talked a ton about this, so I won't spend a ton more time on it. 17 storms, 10 hurricanes, 6 majors. Basically, it was a top 10 season for all parameters. Everyone wants to rank everything, and so we had 6 major hurricanes. The record is 7. For ACE, it was the 7th most ACE back to 1851. So it wasn't the most active season on record, but it was incredibly active. And I think really the thing was, it seemed insanely active because all the storms kind of happened like one right after the other. It was basically August 25th or so till early October was everything. And that was so basically we went just hyperactive during the peak of the season. So how were the seasonal forecasts? Well, the April forecast last year was not very good. We forecast a slightly below normal hurricane season. So it's about as good as my prediction last year that the San Francisco Giants were going to win the World Series. So at least my NCAA pick, I picked Kansas, so at least they made the Final Four, which is better than some people. But again, if you look at the predictions, they increased as the season approached and as the peak of the season approached. And that's typical with the seasonal forecast. The skill is going to improve. We put out our first forecast in April, but that forecast only has modest skill, and I'll show you the skill of that forecast in a minute. As you get closer to the peak of the season, your skill improves. Similarly to the way that your forecast for tomorrow is generally going to have more skill from your 7-day outlook. And that's because obviously there's just less that can change. Once you get to June, July, August, the uncertainty around El Nino shrinks considerably. You know a lot more what the Atlantic is going to look like. The model predictions get better. And so you have more confidence. And again, it's very similar to day-to-day weather. It's a good analogy. And you can see the numbers increased as the hurricane season approached, and especially once we got into early August. And one thing I try to emphasize is that, yes, June and July are part of the hurricane season, but generally, June and July are typically pretty quiet. You might get a few named storms, but not usually a ton of U.S. impacts. You can get a few, but usually June and July are pretty quiet. And then August comes around, everyone says, oh, well, it's a dud. We didn't have much in June and July. And it's important to emphasize that while it is a third of the season from a calendar day perspective, over 90%, 95-ish% of your major hurricanes occur after the 1st of August. So, just because June and July is quiet doesn't mean that you're going to have a quiet season. So it's important to note that, and I think something I want to try to emphasize, especially with this year where everyone's going to be gung-ho, all this announcements before June 1st, just to remind people, June and July, typically not that much happens. And again, so our seasonal forecast in early April last year wasn't particularly good. And so why wasn't the forecast very good? Well, if you looked at any weather blogs, you looked at a lot of articles in the news, they were all talking about, El Nino is going to recur. We're going to see another El Nino event. And this is the forecast from the European Center, so which is kind of considered the creme de la creme of your daily weather model, your climate model predictions. And so it's spaghetti, it's ensemble forecast. So you have 50 members. And so basically you take your initial conditions, you perturb them a little differently, you run them forward in time, and it's supposed to kind of give you the the uncertainty in the forecast. And as you would expect, little small perturbations at the start seem pretty innocuous, and then they grow with time. Obviously, it's kind of the whole chaos thing. And so the forecast from last year, you would say, okay, probably, plus 1-ish degrees Celsius, maybe a little higher. And then the blue dots represent reality. This is what actually occurred. And the European Center was not good, but very few of the other models were very good as well. So basically, the models were very aggressive at El Nino when it did not develop, and we went a lot more with the dynamical models last year. This year, I'm not going as much with dynamical models. I used a little more of my own insights with some of the statistical analysis that I've done for this year's forecast. But again, the models last year did not do very well, and there's a reason why ourselves and other groups primarily went much quieter than what we actually observed, and that's because, again, we thought we were going to have El Nino last year, and that certainly did not pan out. Part of the issue is you have what's known as this predictability barrier, and it comes during the Northern Hemisphere spring, which is fantastic for seasonal forecasts. The winds that drive El Nino and La Nina cycles tend to be weakest during the spring. So small changes in the atmospheric circulation cause big changes in how the ocean responds. So like right now, you basically need to watch the low-level winds in the tropical Pacific pretty much every day and see how those are shifting, how those are changing, because if they can kick off one of these oceanic Kelvin waves, that can cause a whole lot of warming and completely change the circulation. But if those winds don't occur, if you don't get those those westerly winds, you might not get the Kelvin wave, and that's what we saw in, say, 2014. We all thought El Nino was coming in 2014. We just didn't get the winds to pick up strong enough to cause another wave, and we didn't get the warming, and it waited until 2015 when we had a really strong El Nino. So there is this phenomenon known as the springtime predictability barrier. Noah did a great blog a couple of years ago talking about it, how the skill drops during the Northern Hemisphere spring. But there is some skill there, because obviously if there wasn't any, I won't be talking to you guys today about a seasonal forecast. This is the forecast. This is our hindcast skill going back to 1982 with our current statistical model. And the correlation is 0.54. So again, there is some skill here, but the correlations are modest. It's about 25-30% of the variability. If I show you the same forecast for August, you see that this is real-time forecast. So this is our forecast that we've issued every August since 1984. Prior to 2000, I am not responsible. I was not at CSU during that time. I used to remind Dr. Gray when he started doing these forecasts, I was starting my first year at nursery school. But if you go back in time, you see, hey, in general, reasonably good skill, a correlation of 0.75. So there is a lot of skill with the August forecast, and we do have some hindcast skill with the April forecast. And obviously with time, hopefully with model improvements and improved knowledge of the atmosphere-ocean system, as well as improved analysis of historical hurricane seasons, we can improve the skill of the April forecast. I'm not sure if we're ever going to be able to get correlations of 0.8 in April, but even if we can get 0.54 up to 0.6 and 0.7, that would be good. So that's obviously why we're doing this, and we do have some skill when it comes to the seasonal forecast. So last year was really a perfect storm. We had a very warm Atlantic. It was, depending on how you draw the box and which SST product you look at, first warmest, second warmest, third warmest. You're arguing over hundredths of a degree Celsius, which is great. You can kind of pick whatever data set you want if you want to post a tweet about it. But again, it was very, very warm. And we also had a tropical Pacific borderline weak La Nina event, very different from what we thought in early April. And that's a bad combination. Warm Atlantic, cold tropical Pacific, basically all else being equal, you have air going up in the Atlantic, and that's not what you want. You want it subsidence, drying, killing the storms. We also had very, very low vertical shear. So you can have the Atlantic as hot as you want, but if the shear is strong, shear kind of dominates overall. But last year we had very low shear from late August to late September, which is when pretty much all hell broke loose. And you can see the shear was very low, especially in the central Atlantic, where Irma, Maria, and Jose all became very strong hurricanes. From an ACE perspective, while Harvey obviously was a devastating storm, its ACE was fairly low because ACE's frequency, or its intensity and duration combined. And obviously while Harvey got strong, it was strong for a few hours and it made landfall. So from an ACE perspective, it was all Irma, Maria, and Jose were the three large drivers of the ACE. Jose thankfully didn't do a ton of damage, but it was a Cat 4. It was a very impressive storm. Had it not been for Irma, we would have been talking a lot more about Jose. But with a Cat 5 bearing down in Florida, we ignored the Category 4 just east of the islands. But obviously, if all those storms had stayed out to sea, it would have been fun for us hurricane geeks, but really, no one really would have cared that much. But unfortunately, last year, the steering was different. We had an 11-year major hurricane landfall drought for the continental U.S. We had gone 11 years with no Cat 3 plus 111 mile-an-hour wind storms hitting the U.S. Not to say we hadn't seen storms with significant damage. As we all know, Category 1s and 2s, like Hurricane Ike, can do all sorts of damage. But from a major hurricane perspective, we hadn't had one since Wilma in 2005. 2005, Jermaine Dye won the MVP for the World Series. So that tells you how long ago it was, because probably no one remembers who Jermaine Dye is anymore. But you see how the steering pattern was different. We had a very strong high pressure in the West Atlantic, driving the storms that formed further west towards the Caribbean, towards the mainland U.S., and we have a $200 to $300 billion economic damage hurricane season. So last year we were kind of talking about, hurricane amnesia and, how are we going to get people prepared because most areas haven't been impacted in a while, and obviously that's not going to be a problem this year. Certainly people are very amped up and there's a lot of attention being paid to these hurricanes this year, and I can't tell you how many interviews I did last year where it wasn't even about the individual storm, it was just people wanted to know what makes a hurricane, why do we get hurricanes? People just hadn't really thought much about it, and so us people doing hurricane science kind of generally ignored, and for about 3 or 4 weeks, suddenly hurricane scientists were cool people, so that was kind of fun. Obviously, last year was a horrible season. Obviously, 99% of everything was Harvey, Irma, Maria, it seemed like. Obviously, had Ophelia. But Harvey, obviously, first major hurricane to hit the U.S. since 2005. We've heard several talks already on Harvey, so I'm not going to spend a lot of time on it. But it was notable, obviously. It did over $100 billion probably in economic damage. First Cat 4 hit Texas since Carla in 1961, which is what put Dan Rather on the map. That was a storm he covered. It ended the landfall drought since Hurricane Wilma. Dropped over 5 feet of rain in Nederland, Texas. And I think while that was the continental U.S. and the entire U.S. rainfall record from a tropical cyclone, I think one of the things that's more impressive with Harvey isn't just the point total. It was the aerial extent of 3, 4, 5 feet of rain. This is a graphic put together by the National Hurricane Center in their end-of-season report on Harvey, which is a really good read if you want a lot more good data on Hurricane Harvey. Each of these individual measurements, so all the different numbers that you see, all of these would have individually broken the former U.S. rainfall record, continental U.S. rainfall record of 48 inches. So you can just see how much rain fell. And obviously a lot of you live in Houston, so I don't need to tell you how much rain fell. But the highest point totals were actually a little further east than Point Arthur and Beaumont. But obviously, while had Harvey been a well-behaved Texas hurricane, had made landfall in Rockport and it kept going in, it would not be devastating for that portion of central Texas, but in terms of $100 billion price tag, it would have obviously been much, much less. But it was the fact that basically the storm stalled. There was high pressure to the northwest, high pressure to the northeast. The storm basically ground to a halt, but close enough to the Gulf of Mexico was able to entrain all that warm, moist Gulf air and just cause several days of epic rain. And then there was Hurricane Irma, and this storm was just a buzzsaw. It's one of the most impressive. I'd say it looked way more like a super typhoon in the West Pac than what we typically see in the Atlantic. Typically Atlantic storms might get really strong, but usually some sort of shear slams it, and it doesn't last at that kind of intensity for very long. But Irma managed to find one of the lowest shear pockets I think I've ever seen. If you looked at the statistical models, they had like 10 or less knots of shear over Irma for a long time. It was just a really impressively long-lived hurricane. Obviously set all sorts of records. It was the strongest Atlantic hurricane in terms of max winds outside of the Gulf of Mexico or the Caribbean. I think its pressure got down around 912, 914 millibars. 3.25 days is the Cat 5, which tied the Cuba hurricane in 1932. Obviously, we don't necessarily really know exactly how long the Cuba hurricane in 1932 was a Cat 5, so you'd have to put some sort of an error bar around that. But it was a very long-lived Cat 5 for the Atlantic. And it generated the second most ACE in the satellite era from an Atlantic hurricane because it was a very, very long-lived, intense hurricane. It felt like this thing was out there forever as a major hurricane. So it just trailed Hurricane Ivan, which was another very long-lived major hurricane, went all the way across the Atlantic. Over $50 billion in damage. Strongest storm hit the Leeward Islands on record. First Cat 5 hit Cuba since 1924. And its landfall intensity was the 10th lowest for any continental U.S. landfall on record, tied with Carla from 1961. It was the first time we've seen 2 Cat 4s hit the U.S. in a calendar year. But in 1933, we had 2 high-end Cat 3s, 125-mile-an-hour storms, hit the U.S. 23 hours apart. So can you imagine what Twitter would have been like had we had Twitter in 1933? But Herbert Hoover had other things he was worried about. All right, then we had Hurricane Maria, which obviously you've heard a lot about already. A devastating storm blew up, was a Cat 5, plowed into Dominica, slammed the U.S. Virgin Islands that hadn't been already devastated by Irma, and then obviously went into Puerto Rico and did all sorts of damage there. First Cat 5 to hit Dominica on record, and it did about $2 billion in damage in Dominica, which is like twice its GDP. So if you think about that for the U.S., you're talking $40, $50 trillion comparison. So just obviously incredibly devastating for Dominica, the U.S. Virgin Islands, and obviously Puerto Rico. Strongest hurricane hit Puerto Rico since 1928. So again, obviously very, very devastating hurricane season. And on that cheery note, let's move on and talk about 2018. 2018, again, we already highlighted the numbers, so I'm not going to spend a lot more time. 14, 7, and 3, a pretty slightly above normal hurricane season. And there's a lot of uncertainty with the April outlook. When people ask, what's the skill? If you don't want to get into the geeky, variance explained, you can say basically I characterize the April skill as modest, the June skill as good, and the August forecast in general is good to excellent. It just depends, depends on in individual years, but in general the August skill is pretty good. So we use a variety of techniques to come up with our forecasts. Even though I give props to my meteorological namesake Punxsutawney Phil, we try to use a little more rigorous statistics in looking for our shadow. We do have a statistical model that we use, which I'll talk a little bit about now, and our statistical model is generally pretty close to what our final forecast was. We use a total of 4 parameters in our statistical forecast, 2 that kind of assess what's currently going on in the Atlantic and potential some future circulation changes there, and then 2 predictors in the tropical, eastern, and central tropical Pacific, one of which is the European Center sea surface temperature forecast. However, that European Center sea surface temperature forecast has seemed like it's been a little bit warm biased the last few years. They did implement a new forecast system for 2018. But they have hindcasts of that, and his 2017 forecast was even warmer than its old version. So I think it gave me a lot of confidence going into 2018. So I'll have to try to get a little bit better feel for the new model, the new European Center model. But our statistical model, again, does show some variance explained. You get about correlation of 0.54. So these are model fits back to 2010 and then real-time forecasts since 2010. So you can see the model in 2017 said it was going to be slightly below normal, and obviously the model did not do well in 2017. Some of that, again, was if you got rid of the El Nino forecast from the European Center, it would have done a little bit better. We also use analogs, and so this every year, and if you're to ask different meteorologists, climate people, what are your best analogs for any particular time? Obviously, it depends on what you're looking at. What I tried to do was select years in the past that had conditions during the peak of the season, somewhere between weak La Nina and weak El Nino, because I don't think we're going to see strong on either end. And then looked at a variety of different Atlantic conditions. Tried not to get in Atlantics that were super hot, because I don't think we're going to have a really, really hot Atlantic this year. But I don't think it's going to be super cold either. I think it's going to be near normal, maybe a little bit warmer than normal. And so our analogs, again, average out to be fairly close to what our season is. Again, with these analogs, this is looking at the overall season. So it's not to say, you pick a particular year and say, okay, you're going to see storms like if it's 2011 is an analog. Not saying we're necessarily going to see another Hurricane Irene. These are just kind of overall what the general seasonal patterns look like in March, as well as what we kind of think they're going to look like during August to October. So here's kind of the current water temperature anomalies. So we have a weak La Nina event in place in the tropical Pacific. The waters are a little bit colder than normal there. In the Atlantic, the waters are a little bit warmer than normal. In the west, a little colder than normal in the east. And so if the hurricane season started today, it would probably be a reasonably active season. But obviously, the anomalies now may not be the anomalies in August through October. I had to show you the same map from last March. Last March, there was a lot of warmth off the west coast of Peru, so we thought maybe El Nino was coming. And the Atlantic was kind of cold last March, colder than normal. And a lot of things rapidly changed. Because I kind of thought with last season, well, even if the El Nino doesn't come on, the Atlantic doesn't look that conducive anyway. And everything basically just flipped very quickly during the late spring into the summer of last year. But obviously, we got to look at El Nino. That's a huge player every year. This is the formal forecast from the U.S. government. This should be probably updated any day now. Basically, what they do is they give odds. What are the probabilities of El Nino, neutral, and La Nina? And this is usually they use a plus or minus half a degree Celsius. So August through October, they're giving about a 50% chance of neutral, about 30% chance of El Nino, and about a 20% chance of La Nina. And so last year, while the U.S. government was a little less aggressive at calling for El Nino than a lot of the models were. They still were pretty high. They were up about 50 to 60%, but they didn't go as aggressive as the models, which turned out to be a very good forecast on their part. But again, the probability of La Nina they had last year at about 5%, and obviously we saw something very close to La Nina by the peak of the season. But overall, they say the highest odds are of neutral, with lower chances of El Nino and a lower chance of La Nina. So here's the European Center model forecast. It's about evenly split between La Nina and El Nino, but again, I feel like this model's definitely had a warm bias the last few years, so I tend to maybe put a little less stock in this model than I have in previous years. But, if you want to forecast El Nino, it's a pretty crowded business. These are all the models that are currently forecast. Well, this isn't every model, but this is all the models that contribute to the U.S. government and the International Research Institute's page. And so you can see, if you like acronyms, this is for you. I can't tell you what all these acronyms mean, but you have forecasts from the U.S. government, a variety of universities, other countries like the UK, Korea, Japan, Australia. And again, that's because obviously El Nino has impacts globally. So it's in the best interest of a lot of countries to know what El Nino is going to do. And so by August through October, let's dial in here, you can see there's a few models calling for El Nino, most calling for neutral. This model that was calling for El Nino was the climate forecast system. That updates quite frequently, and that has now come up more towards neutral conditions. So it's not down here anymore. It's moved up into this general vicinity, closer to that black line. And again, we have the issue with there is some skill from now through August through October, but it's not that high. So you have to take these forecasts with a little bit, with some caveats. But the ocean has been warming in the eastern and central tropical Pacific. This is upper ocean heat, so the top 300 meters of the ocean have been getting warmer. When you're in a La Nina, they tend to be cold in the upper ocean, and when you're in an El Nino, it tends to be warm. And those have trended warmer. But the key is that you need to have basically wind forcing to basically trigger events that basically cause warming across the ocean basin. And so if you look last year, the black lines, the dotted lines, and the dashed lines indicate these warming and cooling events. And so last year, we had a couple early on, but then it kind of fizzled, so we didn't get El Nino. We had some cooling during the summer into the fall. And then we kind of had very, very weak warming. And then we had a couple of these. Basically, what these are these, the longer dashed lines are downwelling, which are warming waves that come across the ocean, downwelling Kelvin waves. And the smaller dash, the dotted lines, I guess, are upwelling, which is cooling. So typically you get a warming wave and then a cooling wave behind it. And so the question is, every time you get a warming wave, though, it tends to dominate over the cooling wave that comes behind it. So we have seen a couple of these, but I think we still need one more to come if we're going to get a strong El Nino, or we're going to get a moderate El Nino event by the peak of the season. And so what you then look for is, well, what about the winds? Because every time you get kind of these westerly wind events near the central and western tropical Pacific, you tend to get one of these waves coming across. And so you've had some of that recently, but the forecast models basically say, we're kind of done with that. The circulation, if anything, we're going to get some stronger trades. And at least at this point through most of April, the models really aren't predicting any more of these westerly wind events. And I think, as Yogi Berra used to say, it's getting late early. We need, if it's going to go to El Nino for the hurricane season, it needs to happen fairly soon because it takes a few weeks to get the warm water across the ocean basin. It takes 6 weeks or so. So, if we're going to get a rapid transition to El Nino, it's got to happen soon. If you look at the current water temperatures across the tropical Pacific and say, how many times when the waters were approximately this temperature did we go over to El Nino? The warmest it had been now, how warm it had gotten by September was a weak El Nino event at best. Again, that's 12. I had 12 realizations, so it's not a ton. But again, the statistical kind of analysis that I've done says, the warmest it's probably going to be is a weak El Nino for the peak of the hurricane season. Obviously, after that, potentially we could go to a stronger El Nino for the winter. But obviously, for my purposes, once we get through about October 1st, October 10th, I'm good in terms of what I really care about. Obviously, late last year, the Atlantic was really stinking hot. It went from colder than normal to very, very warm late last November. So obviously, if those anomalies have persisted, it would be a much higher forecast this year. But we had a very strong positive North Atlantic oscillation, which basically means a very strong subtropical high pressure system. And on the southern side of that subtropical high pressure system, you have very strong trade winds, which cause a lot of mixing, a lot of cooling, a lot of evaporation, and you get a lot of cooling. And then in the last month or so, the pattern has flipped. Typically what you expect when you get a whole pile of nor'easters along the northeast U.S. That basically flipped the pattern and then kind of caused things to change. But the very strongly positive North Atlantic oscillation caused a lot of anomalous cooling. So obviously the Atlantic cools off every winter, but this is the anomalous cooling. So basically, if it's anomalous warming, that means, relative to normal, it has gone from either, say, colder than normal to warmer than normal. Or if it's anomalous cooling, it means, if you were 1 degree warmer than normal and now you're 0.2 degrees warmer than normal, you had 0.8 degrees of anomalous cooling. So we had a lot of anomalous cooling associated with that very strong North Atlantic oscillation from late November to late February, which is good news. That means less of that nasty warm ocean heat water, less of that warm water for tropical cyclones. And then we had that pattern flip, and so we started to see, again, some anomalous warming. over the last month or so. And these kind of SST, sea surface temperature structures, are classic North Atlantic oscillation forcing structures. You kind of get this tripole pattern. So this is what the current water temperatures look like. So the far North Atlantic is a little bit cold, and the tropical Atlantic is a little warm in the west, a little cold in the east. It looks a little bit like last year. I think it's a little bit warmer overall than last year, but it looks fairly similar to last year in late March. However, last year had a crazy amount of warming, anomalous warming, so don't necessarily expect that that's going to happen again. But some of the models are indicating that we might get some warming. This is the forecast from the Climate Forecast System. This model does have some skill for Atlantic water temperatures this far out. So this is the forecast for August through October. Again, a little bit of warming in the tropical Atlantic. And they're going for basically neutral ENSO conditions. Just a little bit of hurricane climatology. If you're looking for, basically this is the number of hurricanes that have impacted each coastal state. And I use impacts versus landfalls, because just because a hurricane typically makes landfall in one state. You might get a hurricane that hits one state and makes landfall in a second one, but typically you have one state where the storm makes landfall. But when it comes to impacts, you can have several states that had sustained hurricane force winds. One of the ones that used to always drive me crazy with landfalls was Hurricane Hazel. It made landfall right on the South Carolina-North Carolina border. And I didn't want to play the game. It was a Cat 4 in one state and 0 in the other. So if you count it as an impact, it counts as Cat 4 for both. So don't sum these up and say that's the total number of hurricanes that have hit, because they can have some that hit several states. But obviously, and then again, these are states, so obviously some states have more coastline, so they're going to have more chance. But for the general public, hopefully you know what state you live in. Sometimes some people in Colorado, maybe not, but they should, hopefully, most of the time know what state you're in. So obviously Florida, no surprise, had the most, followed by Texas, and then Louisiana and North Carolina, close third, fourth, respectively. This is, again, going back to 1878. And there's a database that the Hurricane Center has. So an impact I count as any hurricane that brought sustained hurricane force winds to your state. And that, again, is a website that the National Hurricane Center maintains that has all that data. So where do the hurricanes that hit the U.S. form? Well, obviously you can tell from here they can form pretty much anywhere, but there do tend to be some pockets, especially when you focus in on the red dots, which are the major hurricanes. And these are the storms that formed where they formed last year. Hurricane Irma in the eastern Atlantic, Hurricane Harvey closer to the islands, and then Hurricane Nate in the far western, right off the coast of Nicaragua. One of the things with Irma was it formed fairly far north for a hurricane to hit the continental U.S. And so if you ever look at the Clipper model, which is the climatology and persistence model from the Hurricane Center, basically all the models took Irma south of due west, and Clipper took it northwest, because that's the way most well-behaved hurricanes go. Irma did not follow that, and so this is what one of my dynamics professor used to tell Dr. Gray, because Dr. Gray was always very big into climatology, and he used to tell Dr. Gray, there's no climatology in the vorticity equations. So that's why we have numerical models. Climatology works great, but there are these kind of outlier events. And again, obviously you can see these storms can form anywhere, but typically you get some in the eastern Atlantic, a bunch by the islands. You kind of see that central Caribbean graveyard, which is due to the fact you tend to have stronger shear there due to the South American landmass. You get a bunch in the western Caribbean. When it comes to the Gulf of Mexico, you get a few in the Bay of Campeche. Not many once you get to the central and northern Gulf. Major hurricanes hitting the U.S. Again, that's because obviously if it's forming in the central Gulf, it's really got to ramp up quick. So you see Alicia, but not a lot. Once you get to the central and northern Gulf, obviously it just doesn't have enough time to hit major hurricane strength. And this one oddball dot up there, east of North Carolina, that's not a GIS plotting error. That was the Yankee hurricane of 1935, which went southwest and hit Florida in November of that year. So we do update the forecast. The skill improves. May 31st will be our next forecast. It's my 38th birthday, so woohoo. What better way to celebrate than putting out a hurricane forecast. Then we'll update it on the 2nd of July and a final update on the 2nd of August. Again, the forecasts tend to have more skill as the hurricane season ramps up. We do have landfall probabilities. These probabilities are based upon the overall number of storms that we're predicting and then adjusted based on our latest forecast. So the probabilities, again, this year are somewhat elevated simply because we're predicting a slightly above normal overall Atlantic hurricane season. Hope in the future to maybe get a little more rigorous with this because the relationships aren't identical state to state. Some states tend to get more, as you elevate levels of activity, some states tend to get hit more frequently than others. Some states, regardless of the season, seem to get hit by about the same number of storms unless it's a really, really quiet season. So that's something we're hoping to do here in the near future. We do have a website you can access which is partnership with the Geographics Lab at Bridgewater State. It was college when I graduated, now it's university, so go Bears, that's my alma mater. So we put together this website where we have landfall probabilities for every state and for every county along the continental U.S. Again, purely based on historical data, and then adjusted based on our forecast. So if you're interested, we have probabilities for individual states. Again, they're elevated this year because we're predicting an above normal hurricane season. And again, I hope to potentially go back and do some more work on this website, hopefully maybe this year. We also have probabilities for the Caribbean. I don't do landfalls for the Caribbean because some of the islands in the Caribbean are very, very small, so it's hard to actually make landfall in those places. Like, for example, Maria didn't technically make landfall in the U.S. Virgin Islands, and that its center of the circulation did not cross over any of the land masses, but obviously the eye wall of the storm went over them, so it doesn't really matter. So I try to do hurricanes within 50 and 100 miles as opposed to actual physical landfalls, because when you get to small islands, landfall becomes a lot less relevant. So you can see how these probabilities are for 2018, again, a little bit elevated this year. I have a couple of new products I've been working on. This website got a little bit of traffic last year because I think people were just interested to see ACE kind of go up asymptotically for a little while during September. It's global tropical cyclone statistics, so you can probably tell I'm a bit of a stats guy. And so what I wanted to do is say, okay, the Atlantic I kind of intuitively knew, okay, we've had X number of hurricanes, we should have had, we're half of normal or twice of normal, but this is the website I built. We have global tropical cyclone stats in real time, so you can kind of see how things compare with normal, because when the Atlantic tends to be elevated, the Pacific tends to be quieter and vice versa, typically. Doesn't work all the time, but generally. And in general, if you're looking for an active global season, you want an El Nino. Because while El Nino knocks down the Atlantic, it increases the Pacific, and if you want the most bang for your buck, you want the Pacific active, not the Atlantic. Because last year, even though the Atlantic was gangbusters, globally the ACE was down. And that's because, again, the Atlantic can only really generate a whole pile of storms in August, September, and into mid or so October, and then it's kind of done no matter how conducive the conditions are. Whereas these other basins have a lot longer seasons that can generate overall a lot more ACE. For example, the Atlantic on average generates about 100, the average is 105, the Northwest Pacific's about 300, so almost 3 times as much ACE in the Northwest Pacific as in the Atlantic in a particular year. Whereas you can see through December 14th of last year, the Atlantic had generated quite a bit more than the West Pacific, and that doesn't happen that often. Last year, the West Pac was like its fifth deadest year since 1950. And if you can't get enough seasonal hurricane predictions, we're not the only show in town. We were till probably the mid-90s or so, and now there's a whole pile of other groups doing these forecasts. We just picked up a 22nd agency submitting to our website. As of today, University of Oklahoma is going to start submitting their forecast. So seasonalhurricanepredictions.org. It was produced by our group at CSU. The Barcelona Supercomputing Center hosts the website and did an awesome job designing it. With a little bit of funding support from XL Catlin, so thanks to them for giving us a little money to put this website together. So we have 21 different groups submitting seasonal forecasts, and with Oklahoma, that'll be 22. And on the website, basically what it provides is the predictions for the various numbers. So number of hurricanes, number of named storms, number of major hurricanes, and ACE. Not every group does all those parameters, but you can kind of gives you an idea of, okay, who's predicting what. And on the website, we have a little short write-up on kind of what the primary issues are for the season. And we also go into detail, and you also have a short discussion from each group as to what their model uses or how they're predicting the number of storms. And then if you click each group, you can get a much fuller write-up on what they're individually using. We have a forum on our website, so each group basically just types in when they have hit their forecast, they type it in, hit submit. So when I design a website, it looks like this. When you get a professional web designer, it looks like this. So that's what happens when you get a professional to do the job. So we're excited. This is our third year. So our forecast isn't on there yet because I need to go to my laptop and type it in. But I believe WeatherBell has already submitted theirs. There's actually a couple other groups putting out their seasonal forecast today and a couple more later this week. So we'll start to see some more. And then usually by late April, we've got about 10 or 12. And then by May, usually you've got about 15 or 20. So if you're interested in seasonal forecasts, I definitely suggest you guys check this out. And with that, I think especially talking to a group that does, most of you guys do predictions and forecasting for a living. This is an admonition from Arago, who was the head of the Paris Observatory in the mid-19th century. And he stated that never, no matter what may be the progress of science, will honest scientific men, and obviously now we also include women, who have regard for their reputations venture to predict the weather. And I would certainly agree with Arago that it is definitely a challenge. And with that, thank you very much for your attention, and I'll try to answer any questions.
Very good. Questions? time for questions?
Fire away.
Come on, wake up, guys.
That's right. I like that one to start out. No offense, but, you know.
Wow.
Yes, sir.
Yeah, how are the statistical probabilities of landfall compare to, like, say, last year's forecast? They look pretty similar to what you put out last year. Are they close?
Yeah, so in April they would have been lower because we were forecasting a below normal.
So those questions and answers may go on for a while inside there, but you heard the official forecast now for this hurricane season. 14 named storms, 7 hurricanes, and 3 major hurricanes. And that is a slightly above average season. A lot of different reasons. You just heard an hour of explanation for why that is. But that is the forecast for the 2017 hurricane season from Dr. Phil Klotzbach at Colorado State University. You saw some great websites, some great references you can use. Of course, we'll be talking more about this on the news the next couple of days as well. So thanks for joining us for this broadcast on Somos Valle, Somos Live at South Padre Island. I'm Tim